So this is the beginning of our test review. This warm-up is not in your packet or anywhere, so please write down the first 3 problems that you can clearly see. We'll pause the video here for you to try them in your tables, and then I will go over the answers, and then we will scroll down and you can see numbers 4 and 5. You'll try them, and then I will go over the answers. So pause the video here to do numbers 1, 2, and 3. So I'm going to fill in my answers by the row. So I'm going to do each function, their period, each function with symmetry, and so on. So for the sine graph, the period is 2 pi. The cosine function has a period of 2 pi, and the tangent function has a period of pi. Symmetry, even means y-axis, odd means the origin, and neither is neither of them. So the sine function is odd, the cosine function is even, and the tangent function is odd. If it helps you, you could make a little sketch of each graph above your chart here. To help you visualize what the graph would look like, the parent function specifically. Between 0 and 2 pi, what are the intervals that produce negative y values? For sine, that is this little piece here, and that is between pi and 2 pi. So pi is less than x is less than 2 pi. For cosine, that would be this piece here, and that's between pi over 2 and 3 pi over 2. So that's from pi over 2 is less than x is less than 3 pi over 2. And tangent, we specifically only have to give answers from 0 to 2 pi. So anything to the left of the origin doesn't count. So for tangent, that would be this piece down here. And there's going to be 2 separate intervals that negative happens on from 0 to 2 pi. That's going to be from pi over 2 to pi. And then it's going to be again from 3 pi over 2 to 2 pi. So now answering in the opposite, what are all the positive y values between 0 and 2 pi? So for the sine graph, that happens between 0 and pi. For the cosine graph, again, I'm going to have 2 answers. That's going to go from 0 to pi over 2, and again from 3 pi over 2 to 2 pi. And then lastly, for tangent, I'm running out of room here. The positive values for tangent go from 0 to pi over 2, and again from pi to 3 pi over 2. All right, and then the last part of this problem, the equations of the asymptotes. Sine and cosine do not have any asymptotes, so you better not have any answers there. For tangent, our asymptotes happen every pi over 2. So we can say those are the vertical lines x equals n pi over 2, where n is an integer. Okay, so for number 2, show how the Pythagorean identity applies for an angle in the standard position through the point 512 on a circle with radius of 13. So the Pythagorean identity says that sine squared of theta plus cosine squared of theta equals 1. Well, sine squared theta, that's an abbreviation for sine of theta squared. So I'm going to rewrite cosine the same way. And now from my picture, sine of theta is 12 over 13. Cosine of theta is 5 over 13. And to simplify then those values, we get 144 over 169 plus 25 over 169. We have a common denominator, and 144 plus 25 is 169, and anything divided by itself is 1. So that matches. We proved that sine squared theta plus cosine squared theta equals 1 for that triangle. Describe all the transformations. There is a vertical dilation of 6. There is a horizontal dilation of 7. And it is a vertical translation, or you could say up, 8. Okay, so here's problems 4 and 5. We'll pause the video again for you to write them down and try those two problems. Okay, so to answer number 4, write an equation of a sine function. So I have to make sure I have sine, and I have to make sure I have y equals an amplitude of 2, so that's the leading coefficient, and down 10. But now a period of 12 pi does not show in your equation. We have to take that and modify it to find our horizontal dilation. So if the original period is 2 pi, and the new period is 12 pi, that is going to be our horizontal dilation value. So reducing the 2 pi over 12 pi, the pi's divided by pi is 1, and 2 over 12 is 1/6. So the 1/6 is our horizontal dilation value. And lastly, for 5, it says write a sine and cosine equation for this graph. There are infinite answers. So if your answer is not specifically one that I have that I'm going to write, you can check with someone at your table to see if maybe they have the one you wrote. But here are the few that I'm going to write. Our midline happens halfway between 2 and -6. So our midline is at y equals -2. I like to put that on my sketch because it helps me with my answers and helps me see where the middle of the graph is for any transformations. So that means the amplitude is the distance from the highest point to the midline. So amplitude is 4. And then the period, we can go from this maximum to this maximum. So that's pi to the right and 3 pi to the left for a total of 4 pi for the period. Okay. So here's the first, oops, I didn't leave myself, sorry, hang on. Forgot about horizontal translations. Okay, so figuring out our b value, that's going to be 2 pi over 4 pi, which is 1/2. And then the horizontal translation, depending on what point I pick, it's going to depend on whether it's sine or cosine. So let me start with cosine. If I look for a maximum, that's shifted to the right pi, so that's minus pi. Another answer could have been to do to the left -3 pi. So left 3 pi is also an answer. Oops. If you don't have this double set of parentheses like I'm writing, you can distribute the 1/2 to both of those values, but it has to be both to the horizontal translation and the x. Otherwise, you need the double parentheses like I'm writing. For the sine graphs, and I'm doing the positive graphs, I'm not taking into account anything that's been reflected. For the sine graphs, I want to look for the midline going to a maximum. So that happens right on the midline, meaning there is no horizontal translation. So we could either write +0 or leave it blank. You don't need anything there. We could do a negative sine function if that was midline going to a minimum. I'll pick that one over here at the left, 2 pi. So that equation would be y equals -4 sine 1/2 x to the left 2 pi minus 2. I keep forgetting that extra parenthesis. Or I also could have gone, if I look on the graph, ooh, that's getting messy now. Sorry, I could have gone to the right 2 pi and then, or had a minus there for the right 2 pi.